Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound shown is AC3 symmetric tricyclic molecule consisting of 3 benzene rings fused to a central 6-membered ring that bears 3 ketone is equal to O groups at alternating carbons, positions 1, 3, 5 of the central ring. This molecule is essentially 10,15 dihydro 5H tribenzo A, F, K, tridene 5,10,15 trione, truxenetrione, or a closely related trione. Moving on to the next step. AC4 axis requires 4-fold rotational symmetry. 90 degrees rotation gives identical structure. This molecule has 3-fold C3 symmetry, not 4-fold. Option B is incorrect. Moving on to the next step. Check for center of symmetry inversion center. Option A. An inversion center maps every atom at X, Y, Z to X, Y, Z. For this planar or near-planar molecule with C3V symmetry, there is no inversion center because the 3 carbonyl oxygens are all on the same face, or the molecule has C3V symmetry, not Ci. Option A is incorrect. And for the final step, the molecule is not chiral because it possesses symmetry elements, mirror planes, that make it a chiral. Option D is incorrect. Check for plane of symmetry. Option C. The molecule has C3V symmetry. It possesses at least 1, in fact 3, planes of symmetry, each passing through one carbonyl group and the midpoint of the opposite C to C bond of the central ring, bisecting the molecule. Additionally, if the molecule is planar or has a molecular plane, that itself acts as a plane of symmetry. These mirror planes make the molecule a chiral and confirm the presence of planes of symmetry. Option C is correct. Number C4 axis exists, only C3. No inversion center exists in a C3V molecule. The molecule is achiral due to its mirror planes. Therefore, the correct answer is C. Therefore, the correct answer is option C.